And welcome to the session and welcome to the Barc 2023 Parmanu series. And yes guys, this is the first episode of Parmanu series going on. That is the daily practice paper, and I've been telling you that after the DPPs of all the subjects are completed, we will come up with another episode of Parmanu, some new version of the Parmanu series. So very good morning everyone, and we have shifted the time to morning because in the night we have now started the GATE 2024 classes, and that is why the Barc classes is now shifted to morning 11 a.m. Yes guys, so quickly update all your friends that the session is now live. Okay, many of students may not be aware about the morning, so just quickly share the session so that many of the students can join it, right? So good morning everyone, keep joining quickly. All right, chalo, let's move forward guys. Students will join slowly. So this is the DPP for the control system, and in case somebody new to my classes, this is a brief intro about me. This is Rakesh. I have secured All India rank 9th in GATE and completed my masters from Indian Institute of Science Bengaluru, and these are my major area of expertise. So yeah, that's what I was specifying. GATE 2024 fundamentals already started from 1st March. That is going on in the evening time. That is why we are now conducting the Barc sessions in the morning time. Okay, so that you get content both morning as well as evening. Those who are looking for Barc 2023, they can come in the morning. Those who are looking for GATE 2024, they can watch it at the night. This is going on daily at 9 p.m. for ECEE, IN and computer science branches, right? So time for the GATE 2024 fundamentals, dear, is the 9 p.m. Is the 9 p.m. Okay guys, let's move ahead. Let us move ahead and let us start with the first question. Let us start with the first question, dear. Let CT be the unit step response of a system with the transfer function k s plus a upon s plus k. If C0 plus e equal to 2 and C infinity equal to 10, what is the values of a and k? Hi, good morning everyone. What is the value of a and k? Come on. What should be the value of a and k? So C0 plus C infinity, but this is a question based on first step response calculation and then taking towards the initial and final value theorem. So respectively simpler question only. Okay, so CT be the unit step response. So what should be CT? Now transfer function has been given to me. We all know that transfer function is the ratio of output Laplace transform to the input Laplace transform, and this is given to you as k s plus a divided by s plus k. And what is going to be the input Laplace transform? 1 by s, because the unit step input is mentioned. Because the unit step input is mentioned. So what should be the CS? 1 upon s k s plus a divided by s plus k. Okay. Now C0 plus initial value, okay, given by the formula initial value theorem, limit t tending to infinity s into xs, right? Yeah, s into cs. Okay, don't have to calculate CT, actually you can directly apply the case here. Okay, limit t tending to infinity s into cs, and that is going to be limit of t tending to infinity, s is multiplied by k s plus a upon s plus k. So ss will get cancelled, and now when you put s tending to infinity, I'm so sorry, s tending to infinity, t tending to 0 to s tending to infinity. Okay, and when you put the s tending to infinity, s to s got cancelled. Okay, this is going to be k 1 plus a by s. I'm dividing by s divided by 1 plus k by s, and s is tending to infinity, so 1 upon infinity is 0. 1 upon infinity is 0. So yeah, agya k. That means the value of k should be equal to C0 plus, which is equal to 2. K ka value 2 hoga. Okay, now let us work on the C infinity. C infinity will be limit of s tending to 0, s multiplied by cs, and then it's going to be s tending to 0, s is multiplied by k s plus a divided by s plus k. S has got cancelled. Put down the s tending to 0. You have a by k, and this value should be equal to 10. A by k is equal to 10. Okay. A by k is equal to 10. No, there is also one more k. So k will also get cancelled. So a is equal to 10 actually. Correct? A is equal to 10. ठीक है, करेक्ट. तो K and A and K respectively, तो A10 K2, option number C. Yes, so what is asked respectively, that you have to be very careful. It is not 2 comma 10, it is 10 comma 2. Now very fundamental mistake we have done, just matching the option, that very fundamental mistake we have done. They are asking the value of A and K respectively. So A is equal to 10 and the K is equal to 2. Be very careful about the language sometimes. Let us move to the next question, number 2. The open loop gain of a unity feedback system is given to you. What is the step response of the system? What is the step response of the system? So dear, what should be the characteristic equation? 1 plus omega n square upon s plus 2 omega n. Correct? Or I can say that it should be s square plus 2 omega ns plus omega n square equal to 0. So s square plus 2 zeta omega ns. What should be this term? This should be corresponding to 2 zeta. Actually 2 zeta omega ns should come. So 2 zeta is equal to 2. So what should be zeta, dear? Zeta is equal to 1, representing critically damped response. Representing critically damped response. Okay. And which of the waveform shows you critically damped response? It is the option number D. Okay. A type of non-oscillatory response which doesn't show any oscillation and it reaches its steady state value as quickly as possible. As soon as possible. Okay. Chalo. This one is negatively damped, that is undamped. Okay. Chalo, so D is the very correct answer. Simple concept question. Next, the second order system with the 0 at -2 has its poles located at -3 plus J4 and -3 minus J4. Okay, the question is undamped natural frequency and the damping factor. Undamped natural frequency is known as omega n, and damping factor, not the damping ratio. They are asking the damping factor. Okay, that should be equal to the alpha. That should be equal to the alpha. Very simple, very foundation question. Okay, एक second, यहाँ पे I think language में mistake है. Okay, whether they are asking alpha or zeta, I'll just rectify it. Let me just check the data. -3 plus minus J4, na? Okay, guys. So what are my poles? My poles are -3 plus minus J4. So question should be omega n and zeta. Cut this as factor, call it as ratio. Let's find the damping ratio, okay? Let's find the damping ratio. Okay, now what is the general formula for the poles? The poles of the second order control system is generally given by the formula. The complex conjugate poles are given by the formula minus alpha plus minus j omega d. Minus alpha plus minus j omega d. So clearly alpha is equal to 3. Alpha is equal to 3. Right. So damping factor 3 यहाँ पे available. That is why damping ratio would be the question. So alpha is equal to 3 and omega d is equal to 4. Okay, acha. Now alpha is equal to 3, which is known as zeta omega n, and omega d is given by the formula omega n of omega n into root 1 minus zeta square. Okay. अब यहाँ से first of all if I divide ना, if I divide 3 by 4, that is alpha by omega d, so omega n will get cancelled. We have zeta upon root 1 minus zeta square. How to calculate zeta from here? How to calculate zeta from here? Very simple logic. Put down the zeta as cos phi. We all know that zeta is also given by cos phi. So under root 1 minus zeta square is sin phi. Okay, so we are actually getting tan phi. यहाँ से आप zeta का value निकाल सकते हैं, or you can solve from here as well. These are the two options. Okay, even if you wish, you can solve it up directly. Okay. Acha, one more thing. Alpha, which is zeta into omega n. One more thing. Now let's explore the options also. Alpha is zeta into omega n. Na? Okay, so that is equal to 3. So 3 into 0.8 is 4. 3 into 0.8 is 2.4. 5 into 0.8 is 4. 3 into 0.6 is 1.8. 5 into 0.6 is 3. So, guys, according to me, only possible option is D. Only possible option is D. Which is satisfying alpha is equal to the product of zeta and omega n. Okay, that is only possible option equal to D. Okay, so no need to solve also. No need to solve. अब यहाँ से अगर आप solve करोगे तो you will get 9 minus 9 zeta square after squaring is equal to 16 zeta square. That is why you have 25 zeta square is equal to 9 and under root लेके zeta is equal to 3 divided by 5, that is 0.6. आ गया ना? Then similarly omega n can be calculated, guys. Okay, next question then. Let us move to the next question here. A unity feedback system has the GS given to you. K s plus 2 upon s plus 9 s plus 2. What is the value of K to yield 10% error in the steady state? 10% error in the steady state. For what input? Of course, it is giving you a finite error, and the type of the system is, okay, the type of the system is 1. It has one pole at origin. The type of the system is 1. Okay, so what should be the value of K to give 10% error? Error to what? 10% error due to unit ramp. This is not mentioned. It's understood that if it is a finite error for type 1 system, it is only due to unit ramp. It is only due to the unit ramp. So let us calculate this then. Okay. Okay. Now error due to unit ramp is given by the formula 1 upon kV, right? Where what is the value of kV? kV is given by the formula limit of s tending to 0. S is multiplied by GS. This is limit s is tending to 0. S is multiplied by GS, which is K s plus 2 divided by s plus 4, s plus 9. S got cancelled, and you are getting 2 divided by 4 into 9. 2 is divided by 4 into 9, that is 1 by 18. Okay, now steady state error is 10%. 10% matlab 0.1 absolute value, right? And that is 1 by kV, or that is 1 by kV, and 1 upon kV, reciprocal of this will become 18 divided by k, right? So k kitna ho jayega? 18 is divided by 0.1, and that is equal to 180. K is equal to the 180. Correct answer is B. Correct answer is B. Moving ahead to the next question. What is the next question? Which of the following statement is correct for the open loop transfer function? For the open loop transfer function, GS is K s plus 3 upon s minus 1 for K greater than 1. You have to talk about both stability of closed loop system and the stability of open loop system. You have to talk about the stability of closed loop as well as the open loop system. So guys, very clearly, if I talk about the open loop poles, they are s equal to 0 and 1. Open loop poles means poles of GS. Poles of GS, and the open loop system has one pole in the RHP. So it is unstable. The open loop is unstable. Clear? That is very obvious. Now closed loop, see, you may need to go to RH or you may not need to go. Okay. For closed loop stability, the closed loop poles we also know are known as the roots of characteristic equation. The closed loop poles we all know is also known as the roots of characteristic equation. So sir, what are the roots of characteristic equation? That is 1 plus K s plus 3 upon s minus 1 equal to 0, and hence I have s square minus s plus ks plus 3k equal to 0, or if I combine the terms, s square plus s into k minus 1 plus 3k equal to the 0. Plus 3k equal to the 0. S square plus sk minus 1 plus 3k is equal to what? Is equal to the 0. Correct? Now, for k greater than 1, it is clearly mentioned k greater than 1. K greater than 1. So, ये तो positive ही हो गया. K minus 1 will also be positive because k is greater than 1, and k greater than 1, so of course it is positive. So, 3k also positive. So, do I need to go to the RH? Actually not required, because all the coefficients are of the same sign. And because all coefficients are of the same sign, for second order, na, higher order ke liye we may go to Raut-Hurwitz. For second order, if all coefficients are of the same sign, then the system is stable. So, closed loop unstable, but the open loop is, open loop was unstable, but the closed loop is stable. Answer is B. Everybody? Answer is B. Yes, Himanshu and Ravi Teja? Correct. Yes, Ayush, open loop is unstable. Correct. Closed loop is stable, open loop is unstable. Moving ahead to the next question, number 6. The characteristic equation of an LTI system is given to you. When the system is marginally stable, what is the value of K and the sustained oscillation frequency respectively? Sustained oscillation frequency respectively. Dekho, I'll tell you, because it's a cubic equation, na? You have a third order system given to you, and guys, for the third order directly you can apply the shortcut. What is the shortcut? Chalo, if you don't want to apply the shortcut, let me tell you the method first. ठीक है. अगर complete array से, the shortcut is coming by Routh array only. The shortcut is coming by Routh array. But if I make the Routh array actually, if you have to solve from the scratch, so s cube alternate coefficients will be 1 and 5, and s square mein aa raha hai k, and then equal to the 10. S raised to the power 1 will become 5k minus 10 is divided by k, last element 0. S ki power 0 will be x into 10 divided by x, so this is equal to 10 and 0. Okay, right, 10 and 0. Okay, it is very understood that k is by default positive, so k positive hai, and if k is positive, what I need, 5k minus 10 also should be positive. Okay, so that all coefficients are of the same sign. But हमें same sign नहीं चाहिए, हमें marginally stable चाहिए. And guys, for marginal stability, you have plus minus j omega roots. You have pure imaginary roots. Okay, and that is only possible when you have auxiliary equation. And auxiliary equation is only possible when you have a row of 0. And row of 0 कहाँ पे आता है? Row of 0 आता है odd power row में. Okay, so what you have to take is, you have to take actually this coefficient equal to 0. Odd power row है ना? So let's make 5k minus 10 equal to 0, and you are going to get k is equal to 2. Clear? You are going to get that k is equal to 2. The value of k is equal to 2. Acha, if k is equal to 2, then what is my auxiliary equation? Auxiliary equation is made by the row above row of 0. So above the row of 0, you have s square row. The coefficient of s square will be k plus 10 s ki power 0. So k s square plus 10 equal to 0. That is 2 s square plus 10 equal to 0. K ki jagah 2 rakh diya. So s square is minus 5, and s is equal to plus minus j root 5. All right, the s is equal to plus minus j root 5, and that you can compare with the plus minus j omega. Omega is root 5, so this occurs for k equal to 2 and omega equal to, oh, ye j nahi hona chahiye, that's a typo error. Okay, the frequency na, so it is root 5. K is equal to 2 and root 5. Clear, everybody? Okay, let's make it as d. K is equal to 2 and root 5 is the correct answer. Now, what I was telling you, the shortcut for the cubic equation, as cube plus bs square plus cs plus d equal to 0. For the system to be marginally stable, the inner product should be equal to the outer product. The inner product b into c should be equal to the outer product. Product of means is equal to product of extremes. Okay, product of extremes. So directly you can take that. Okay, and for stability, BC must be greater than AD. अब यहाँ पे जो question है ना, in this the condition for marginally stable, product of means, that is k into 5, should be equal to 1 into 10. तो आ गया ना यहाँ से, how much? K is equal to 2. But how to get the auxiliary equation from here? Right. Auxiliary equation from here. Auxiliary equation is always the even power equation. It is an equation containing all even powers. So you can start with s square equation. So that is k s square, and then alternate only even powers. Okay, so next is s ki power 0 term, that is 10 equal to 0. Right, k ki jagah 2 rakha, to 2s square plus 10 equal to 0, and hence s is equal to plus minus j root 5. S is equal to plus minus j root 5, which you can compare with plus minus j omega. Okay. So for cubic equation, you must be knowing this shortcut. Very, very repeated and important questions can be there on cubic equation directly or indirectly. Okay. So inner product equal to outer product. And for stability, BC must be greater than the AD. Chalte next question ki taraf. The loop transfer function of a LTI system is given to you. For k greater than 0, the point on the real axis that does not belong to the root locus. Very simple question. Point on the real axis. Okay, the point on the real axis, and for that, let me quickly draw the pole 0 map. Okay, so poles are at origin. Okay, then there is a 0 at -1, then there is a pole at -2, there is another pole at -3, and then there is a 0 at -5. Clear? This is the story. Now, root locus exists on a section of real axis as per what? As per odd number criteria. Okay, as per odd number criteria. That is, forward poles and zeros must be odd number. Total FPZ, I mean forward poles and zeros. Forward poles and zeros. Okay. Amrinder, I don't know that. You have to check with the app. I don't know about that. You have to check with the counselor with the app. Okay. So guys, forward poles and zeros. Okay. So let us see all the possibilities. Then we can match up the option. इसको पूरा ही बना लेते हैं. Okay. So if I check the forward poles and zeros from here, 1, 2, 3, 4, 5 poles and zeros. So yes, 5 is an even number. If I check the forward poles and zeros on this section, right? On this section, तो 4 is even. If I check from here, 3 is odd. यहाँ से देखेंगे तो 2 is even. यहाँ से देखेंगे तो 1 is odd. If I see here 0 is counted in even. Okay, so root locus will exist where? Root locus will exist between 0 and -1, between -3 and -2, and to the left of -5. These are the existence regions of the root locus on the real axis, right? So -0.5 does not belong. तो ये belong करेगा. ठीक है, this is on root locus. Right, -2.5, yes sir, on root locus. -3.5, that is in the even number criteria. This is the correct answer. Right, -5.5, that is also on the root locus. Okay, so only option number C has the point which does not belong to the root locus of the system. Clear? Which does not belong to the root locus of the system. Chalo, great. Moving ahead to the next question. Okay, a unity feedback system is shown in the figure 1. All right, the root locus of its characteristic equation is shown in the figure 2. Okay, if P -5, 0 is a point on the root locus, so there is a point on the root locus, what is the value of K? What should be the value of K? If the point P lies on the root locus, what should be the value of K? What should be the value of K? What is the formula I'm going to use? Okay, to find the value of K. So see, if GS is given, we can use the formula that the point should satisfy the characteristic equation. The point should satisfy the characteristic equation. All right. Okay. So what is the value of the parameter K? Number one method. Modulus of KGS equal to 1, or number 2 method. The value of K is given by the product of all the distances from poles divided by product of all the distances from 0. Okay, so if this is the point P, okay, there are 2 poles given. Okay, this distance is known as P1, and suppose this distance is known as P2. And there is one 0 also given at -3, and this distance is suppose known as Z1. Okay, so the K will be given by the formula product of all the distances with respect to poles divided by product of all the distances with respect to 0. So there is only one 0, the distance ho gaya Z1. P1, P2 is divided by Z1. P1, P2 is divided by Z1. So what is the value of P1? -5 se -2 distance hua 3. -5 se -1 distance hua 4. Distance of Z1, so -5 to -3 distance is equal to 2. Okay, so correct answer 12 by 2, it should be the 6. The correct answer should be the 6, option number C. Correct, Himanshu? Correct answer is option number C. So variety of miscellaneous questions, Routh-Hurwitz, root locus, transient analysis, steady state error. We are learning with this sheet and many more questions to come up. Guys, this time what I have done is, if you have observed in the Telegram, I have already shared you the DPP in the Telegram. Yesterday night also, morning also. Okay, we have shared you this daily practice paper. The idea was, we'll send you the questions in the PDF. You try to solve, and then you want to know, what is the answers you have done wrong, what is the correct answer, what is the correct approach. Okay, for that you can watch live. Okay, so this time what I have done is, yesterday night, have you got that PDF, guys? Have you checked that PDF in the Telegram? It was shared once in the night and once in the morning as well. Have you received that PDF? Have you received that PDF? In the PDF format we have shared it. Okay, so that you can come live and discuss with the question. Nahi dekha hai to no problem, we are discussing here. Okay. Yeah, you have received that? Chalo, good. Okay, dear. Okay, the state equation for the state diagram shown in the figure. Okay. For the state diagram shown in the figure. Okay, so let us have a look into this. Okay, the clearly state variables are defined. This is x1. So let me call it as x1, x1t in time domain. So if the output of any integrator, okay, if the output of any integrator, guys, is x, what is going to be its input? You must know this if you have studied state space. If the output is x, चलो logic से निकाल देंगे इसमें state space क्या ही है. Okay, if the output of integrator is x, okay, what should be the input? The input should be the reverse derivative, na? Okay. If the output is integration, the input should be differentiation, x dot. Because derivative and integral will cancel and will give you x. So what I should write here, dear, I'll write here x1 dot. Okay, similarly, this is x2 given to me. So this has to be x2 dot. Dot बोले तो derivative. Clear hai? Okay, chalo, great. Now, let me write down the equations then. Let me start writing the equations. Dekho, what is the value of x1 dot? Starting with x1 dot. Only state equations are expected, na? Correct. Only state equations are expected. So what is the value of the x1 dot, dear? What is the value of the x1 dot? Dekhenge. The x1 dot, okay, x1 dot number 1 has this feedback line minus p1 x1. Okay. Plus 1 into what? What is this actually? ये निकालना पड़ेगा यहाँ पे, because this is also having incoming lines. This is not a simple node, but it is like a summing node here. Okay, so what is this? x2 z2. x2 z2. One of the is x2 z2, and one of them is x2 dot c. But in the state equations, the right hand side should not contain any derivative terms. Okay, so what is x2 dot? वो भी लिख लेंगे यहाँ पे. So that x2 dot is coming and repeating here. Okay, it is x2 z2 plus x2 dot I can say, but what is that x2 dot? Don't write down in terms of derivative and right hand side. So x2 dot देखेंगे minus p2 x2. Okay, that is minus p2 into x2 plus one more incoming line, that is from the input, that is equal to a into r. A into r. So what is x1 dot? x1 dot is equal to, dear, x1 dot is equal to minus p1 x1 plus 1 into this node, and this node is equal to सबसे पहले लिखा x2 z2 plus the x2 dot, that is equal to minus p2 x2 plus a into r, right? Plus a into r. So dear, rearranging it, what is the x1 dot? Okay, x1 dot minus p1 x1. Okay, और यहाँ से मैंने x2 को कॉमन लिया तो z2 minus p2 multiplied by the x2 plus ar. Okay, so let me rewrite this equation here once again. Just a moment. Okay, x1 dot is equal to how much? x1 dot is equal to minus p1 x1 plus z2 minus p2 into x2 plus a into r, whereas what is x2 dot equal to? That is only equal to minus p2 x2 plus ar. Minus p2 x2 plus ar. Clear, everybody? That is the value of x2 dot. Okay, so now when you write this in the matrix form, x dot is equal to minus p1 z2 minus p2 0 minus p2 into x plus a r. This is like x dot is equal to ax plus bu. X dot is equal to ax plus bu. Now let us match with the options. Okay, so I have this is aa, okay, and then यहाँ पे 0 था, correct. Then let me check minus p1 and z2 minus p2 and 0 minus p2. Perfect. So a option should be matching up. The correct answer for the question is option number A. The correct answer for the question is option number A. ठीक है, done है. The state equation of a LTI system is given to you. What is the state transition matrix? Okay, dear. The state transition matrix, STM, known as phi t, or that is also defined as e raised to the power at, and to calculate it, we apply the formula inverse Laplace transform of Si minus a whole inverse. Inverse Laplace of Si minus a whole inverse. Okay, so what is that Si minus a calculation? Let us start that. Si minus a minus the A matrix 0 2 minus 2 0 0 2 minus 2 0. Okay, just a second. ठीक है, चलो डन है. Okay, so let's get moving ahead. So how much is this equal to? I was just trying to check one data. So s minus 0, then 0 minus 2, and then this is 0 minus minus plus 2, and then again s minus 0. This is s. Correct. ये si minus a हो गया. So what is the si minus a whole inverse? Okay, that is given by the formula adjoint of si minus a divided by modulus of si minus a. What is the adjoint of si minus a? What is the adjoint of si minus a? Okay, for a 2 cross 2 matrix, adjoint means exchange the diagonal elements and change the sign of these two numbers. Don't exchange them. So change the sign. Minus 2 becomes plus 2 and 2 becomes minus 2. Divided by the determinant of si minus a, that is cross multiply s square minus of minus 4, that should be written as plus 4. Okay, so this is the si minus a whole inverse. Let me write down once again. We also call this as the term phi s, si minus a whole inverse, and this is given by divide s square plus 4 throughout, to s upon s square plus 4. यहाँ पे भी है s upon s square plus 4. Then second term we had plus 2. So that is 2 upon s square plus 4 and minus 2 upon s square plus 4. ठीक है. So what should be the value of phi t? Okay, inverse Laplace लेना है. Just one step, take the inverse Laplace of this calculation, and when you take the inverse Laplace, s upon s square plus a square, s upon s square plus a square, s upon s square plus a square, cos at, so cos 2t, here also cos 2t, 2 upon s square plus a square, okay, that is sin 2t, okay, and minus 2 upon s square plus a square, so minus sin 2t. So your answer should be cos sin minus sin cos, and that is option number A. Everybody, the correct answer here is option number A. That's it. The correct answer is the option number A. Let us move to the next question. Okay, number 11. All right. Okay, the state representation of a system is given to you. What is the response of the system? The state representation of a system is given to you. Now, please see the state representation here. X dot is equal to AX. Okay. Jitpal, definitely you can trust that college for academics as well as for placements, Jitpal. So x dot is equal to ax, or we can say that x dot is equal to ax plus bu. Okay, but if this is mentioned, if this is not mentioned, that means u is equal to 0, x dot is equal to ax, matlab u is equal to 0. So what is the response that you need to calculate is the zero input response. The response under zero input condition. So the response that you have to calculate is the zero input response. Okay, and what is the formula for zero input response? पहले state vector solve करेंगे. Okay, now what is the output? Right, this is like y is equal to 1, 2 and x. X means x1, x2, the state vector containing both the state variables. So y is equal to x1 plus 2x2. Okay, so first you should find the xzir. Okay, first you have to find the solution of the state vector xzir, and that is given by the formula phi t into x0. x0 is the initial condition. What is the phi t? State transition matrix. x0 is known as the initial state and phi t is known as the state transition matrix. अब state transition matrix कितना होगा यहाँ पे? You have the matrix A as 2 0 0 3. A shortcut can be applied here. Let me add that shortcut. Okay, that the given matrix is a diagonal matrix. Now you can calculate the state transition matrix as the previous question. I have explained you. As the previous question, you can calculate this once again. Not a big deal. Okay, as I have explained you. But what is the shortcut? E raised to the power at. Okay, for a diagonal matrix, take the exponent of the diagonal numbers, e power 2t and e power 3t. Others will be 0. So state transition matrix will also be a diagonal matrix. That is a direct shortcut. If you don't know, you can note that down. Otherwise, how to calculate state transition matrix? Previous question पूरा मैंने explain किया. You can refer to the previous question. Okay, so now you have to just come and substitute here xzirt. xzirt, as I told you, which is phi t into x naught. Phi t is the state transition matrix, and this is already seen e power 2t 0 0 e raised to the power 3t multiplied by the initial state, which is given to me as 0 1. Now multiply e power 2t into 0 plus 0 into 1. Ye ho gaya 0. 0 into 0 plus e power 3t into 1. So the second is e power 3t. Now as I told you, state vector is the vector containing both the states. So sir, this is x1 and this is the x2t. So these are values of both the states, x1 and x2. So what is the final ZIR? Right, y, ZIRT. And as I have written formula earlier, y is given by x1 plus 2x2. x1 plus 2x2. x1 0 hai, plus 2x2. So the final answer is 2 e raised to the power 3t. 2 e raised to the power 3t. Correct answer is C, dear. The correct answer is C. Yes, Himanshu Kumar. The correct answer, the very correct answer for the question is equal to C. Done? Chalo. Moving ahead to the next question. Any doubts, please ask me. Okay, these are all important questions. Moving ahead to the next question. A linear time invariant system is described by the input ut, output yt. Okay, is described by the state space representation as given below. X dot is equal to x2, x2 dot is x1 plus x2 plus u, and y equal to x1 plus 3x2. What is the transfer function? So guys, let us convert this. X dot is equal to x2, that is 0 1. Okay, x1 is absent, x2 is present. Okay, and then x1 plus x2, that is 1 1 x plus first mein there is no input, second mein it is equal to 1 into u. And what is the output equation? Y is equal to 1 and 3x, x1 plus 3x2. So 1 and 3. Now dear, what is the transfer function? Now we know the matrix A, B, C. The transfer function is given by the formula. C phi B plus D. Okay. The transfer function is given by the formula, method number 1, the formula that is C phi S into B plus matrix D. Number 1 way. Okay, but I can make this particular question simple. How? So if you have studied state space, you should be able to recall what type of model is this. Anybody? What type of model is given to me? What type of model has been given to me? X dot is equal to AX, where A is 0, 1, okay, and then A naught A1 minus A naught minus A1. This is 0 BU, and Y equal to C naught C1X. This is the form which we commonly know as CCF form. Known as what? Controllable canonical form. The controllable canonical form. Correct. So use the CCF model. Now, what is that CCF model? Why this overlapping is happening? Let me rewrite this. Okay. What is that CCF model? Okay. A 2 cross 2, a second order CCF model. The transfer function, if suppose given as B, C1S plus C naught divided by S square plus A1S plus A naught, then its state space model is defined as X dot is equal to AX, where A is 0 1 minus A naught minus A1. Dekho, first row is fixed 0 1. Okay, second row starts with the constant of the denominator, constant of characteristic equation, then go to the next A1, both are of opposite sign. X dot is AX plus 0 B U. What is B? If there is some common in the numerator. And Y is equal to C naught C1X. What is C naught? The constant of the numerator. So here we start with the constant of numerator, then the next term C1, both of the same sign. अब यहाँ पे मुझे given है, what is given to me? Please pay attention. What is given to me? 0 1 1 1 x plus 0 1 u. Y is equal to 1 3 x. So what is my transfer function? It is b. B का value 1 है, right? This is c naught, this is c1, right? So c naught 1 है plus c1s, that is plus 3s divided by s square. Now this is minus a naught. This should be minus a naught. Okay, that means a naught का value minus 1 है, and then this is minus 1 into s. Next is minus 1 into s. Okay. So what is this? This is actually 3s plus 1 is divided by s square minus s minus 1. Divided by s square minus s minus 1. The correct answer goes to D. Okay, correct answer goes to D. D, Himanshu. 3s plus 1. S plus 3 nahi na? S plus 3 nahi. This is c naught c1. C naught means constant and c1 means the coefficient of s. So it should be 3s plus 1. Numerator ko thoda sa dhyan de dena. Okay, that is in the regular order, c naught c1. C naught being the constant term. The constant is equal to 1. Okay, so D is the correct answer, dear. D is the correct answer. Moving ahead to the next question. Okay, a very regular Bode plots question. The approximate Bode magnitude plot of a minimum phase system is shown in the figure. What is the transfer function of the system? Okay, what is the transfer function? So can we try to match it by some techniques? Let's see. This is the frequency 0.1. If it is not clear, I will write down here separately. 0.1, 10, 100. This is 20, 140 and 160. That is clear, I think. Right? Now, what is the slope of this line? Let me write down the slope of this line. Okay, slope of this line is equal to change in magnitude, 140 minus 20, okay, decibel, divided by how much change in frequency? 0.1 say 10. 0.1 say 10. That is into 10 into 10. 0.1 into 10 is 1. 1 into 10 will be 10. So how many decades? A factor of 10 is 1 decade. A factor of 10 is known as 1 decade. So this is 2 decades actually. Okay. So this is 120 by 2. That is 60 dB per decade. Okay. Then how much should be the slope of this line? How much should be the slope of this next line? Okay, this is 140 minus 160 minus 140 and this is into 10. That is 1 decade only. So 160 hai. 160 minus 140 decibel divided by 1 decade. Okay, and that is known as 20 decibel per decade. So this slope is 20. And this slope, this slope came out to be 60. This is 60. And then this is again 0 dB per decade. This is parallel to x-axis. So guys, what can I comment that? At this particular point, the slope increased by 60. It was 0, parallel to x-axis, and then becomes 60. So this should be 3 zeros because there is a plus 20 increase due to a single zero. So here there are 3 zeros. Okay, let us talk about this point. 60 to 20, so it reduced by 40. 60 say 20, it reduced by 40, and reduction of 40 is by 2 poles because 1 pole will reduce by 20 dB per decade. Okay, and then 20 to 0, it reduced by 20. 20 say 0, it reduced by 20. Dear, what? It reduced by 20. That means there is a single pole. Reduction of 20 is due to a what? Due to a single pole. So here there is a single pole. Done? Here what? There is a single pole here. Okay, guys. Now 3 poles, 3 zeros at what? 0.1. So s plus 0.1 का cube होना चाहिए. Okay, that is there in ACD, ABD, सब में निकालना पड़ेगा I think. Then s plus 10 whole square, s plus 10 का whole square. I think solved. I think question solved, guys. I told you, maybe we don't have to solve it up completely. So question is solved here. The question is solved here. The question stands to be solved here. Correct answer is A. Okay. By 3 zeros, again I'll tell you, 0.1 का cube, 0.1 का cube, 0.1 का cube. But there are 2 poles at 10. So s plus 10 denominator में whole square, that is only available here. Out of the ABD, it is only available here. So by option matching we are able to see. Okay, by option matching we are able to get the answer is equal to A. Okay, chalo, done hai. Himanshu, you solve and let me know if you have any doubts. Okay, unnecessary I have to solve many other questions. Okay, K का value कैसे निकालोगे? I'll tell you only thing is यहाँ से आप निकालोगे because it is a type 0 system, initial slope is 0. This is 20 which is equal to, one thing I will tell you Himanshu, 20 is equal to 20 log K, right? तो K का value 10 होगा यहाँ से, but then you might be feeling why 10 is not in the option. You might be feeling why 10 is not in the option. I'll tell you what you have to do actually. The K is the K when you write down the transfer function in the standard form, time constant form. Right. So first you calculate from here. In the standard form answer will be 10 only, 100%. But why it is not 10 here? Because options are not standard. What you will do is, ye aa gaya 10. Okay. Then you have a 0 at 0.1. So what will you write? 1 plus s divided by 0.1. 1 plus st, and t is equal to 1 upon corner frequency ka whole cube. Right. Divided by etc. 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 Okay. Divided by 1 plus s by 10 ka whole square. 1 plus s by 100. Ki power 100, there is one pole. Clear? Now you just have to simplify this. Can you do that last mein? Okay. So you have to write s plus 10 ka square. So 10 square, then 100, 0.1 cube. You have to just adjust these terms. You will get the 10 power 8 also, 100%. Okay. So just one last calculation I leave to you that you can do. Okay. So from the Bode plot, the value of K you get is the time constant form in the standard form. Okay. So this is the standard form. Here K will be 10. But if you rearrange, okay, you get it A. Nana Gautam, K is a constant term. It can come in any form. It's not like that. But the standard formula that you have Bode plot, what is the initial part formula? What is the initial part formula? मैं उस फॉर्मूले की बात कर रहा हूं. Initial part formula, magnitude is given by minus 20n log omega plus 20 log K. Okay, and n is known as the number of poles at origin. The point is, this formula is derived when the transfer function is in the standard form, time constant form. That is why if you are calculating K, okay, that should be the K of time constant form. Okay. Okay. So K constant kahin pe bhi aayega. Here also constant is coming, but formula mein that constant will come which is in the time constant form. That is the thing I want to mention. Okay. Right. Here n is equal to 0 because initial slope is 0. This is known as what? This is known as the slope of initial part, which is also known as the initial slope. And initial part is parallel to x-axis. That is why n is equal to 0. Clear? Hai? Now, okay, so I think just a small rearrangement. You will get 10 power 8 also, but option match ho gaya. Moving ahead to the next question here. The open loop transfer function of a system is given to you. GSHS equal to 100 s plus 100 upon s plus 10. In the straight line approximation of the Bode plot, mod Gj omega Hg omega at omega equal to 100. So at the omega equal to 100, what is going to be the magnitude, okay, by the Bode plot in the straight line approximation of the Bode plot? Okay, in the straight line approximation by the Bode plot. Now once again, is it the time constant form given? No. It is not the time constant form given. So I will have to convert into time constant form. Numerator say 100 common. So 1 plus s by 100 divided by s. Denominators I take 10 common. So 1 plus s by 10. Okay. Now this is equal to 10 ki power 3000. 1000. 1 plus s by 100 divided by s. 1 plus s by 10. So what are your corner frequencies, dear? What are your corner frequencies? Corner frequency, अगर मैं 0 की बात करूं, due to the 0, corner, if you have the time constant form, corner frequency is 1 upon t, right? Corner frequencies 1 upon t, that is 100. Right. If you want to talk about the pole term, what is the corner frequency? Right. It is again 1 by t. T is 1 by 10 for the pole. So corner frequency is 10. So there are two corner frequency. Initial part की बात करें, the formula I just told you. Like n का value कितना है? N is equal to 1. Right. So if I write down the initial part calculation and then start drawing the Bode plot quickly. Minus 20n log omega plus 20 log k. Plus 20 log k, half an hour. Okay. So what is the value of the magnitude? What is the value of the magnitude? Initial magnitude हो गया n का value 1 है, so minus 20 log omega plus 20 log of k. So again see which k, which is in the time constant form, 1000. Okay, so 10 की power 3, 10 की power log of 10 की power 3 will be 3, so this is equal to minus 20 log omega plus 60. Okay, plus 60. So अब देखो start करते हैं Bode plot को roughly so that I get my answer. Okay, let me start with the omega equal to 1. Let me start with the omega equal to 1. I want the omega which is below the corner frequency. So guys, omega equal to 1 starting में तो 20 log 1 is 0. Log 1 is 0. So I will start with 60 dB. And initial slope will be 20. And now when I reach omega equal to 10. Okay, so that is one decade only. Omega अगर 10 पहुंचा तो slope is already minus 20 decibel per decade. Slope is already minus 20 decibel per decade. So magnitude will decrease by 20 for one decade. So it will come to the 40. Quick calculations, mind calculation se chalna hai. Now I stop at 10 because 10 is a corner frequency. Corner frequency due to what? Due to a pole. Due to a pole, the slope will further decrease. Due to the pole, the slope will further decrease. This is the slope minus 20 decibel per decade. Now it will further decrease. It will further decrease. Okay. Just a moment. Okay, at this the slope will further decrease. And what is the magnitude at 100? That is expected to you, no? So now you will have a slope. This was minus 20 slope. Now you will have a slope of minus 40 decibel per decade. Now you will have a slope of minus 40 decibel per decade. And you have to see what is the magnitude at 100. Okay, तो निकाल लेते हैं. The slope of minus 40, please pay attention. The slope of minus 40, please pay attention. Okay, so minus 40 slope is given by, now what is going to be the next magnitude at 100? Let's say that is m. Minus, what is the magnitude I am starting here? 40. Divided by, hey, what is the slope formula? In Bode plot, what is the slope formula you apply? Change in magnitude. Divide by change in log omega, because x-axis is log omega actually. So divided by log omega 2 minus log omega 1. So log of omega 2, I am going to log 100. I am going to go to log 100. ठीक है. अच्छा, डायरेक्टली निकाल लेते हैं ना. अगेन जस्ट डायरेक्टली आई कैलकुलेटेड, वही माइंड कैलकुलेशन से चलते हैं. सॉरी, आई एम गोइंग टिल 100. लिसन टू मी, आई एम गोइंग टिल 100. ओके, दैट मीन्स वन decade. That means it is going to be one decade. And the slope is minus 40 decibel per decade. That means the magnitude will drop by 40. The magnitude should drop by 40. Magnitude should drop by 40. So already I am at 40. Where will I come? I will come up to the 0. I will come up to the 0. The magnitude will be exactly 0 at omega equal to 100. So that is why the question becomes simple. Only mind calculations are required. Okay. Because the frequency, luckily, that is given is already in the form of decades. If it is not in form of decades, I will use this formula to calculate the magnitude. Right. So I stop here. Okay. But just to tell you that omega equal to 100 is another corner frequency that is due to 0. That is due to 0. So slope will now increase by 20. Slope will now increase by 20, and the next slope will be minus 20. And this was the last corner frequency. Minus 40 plus 20 minus 20. Now this was the last corner frequency. So this portion will go till infinity without any change. Okay. So the correct answer here is magnitude being 0 dB. Okay. Magnitude being 0 dB. Correct answer is A. Everybody. Clear hai? The correct answer is equal to what? Is equal to the A. All right. Done hai? Moving ahead to the next question. From the given Nyquist plot, calculate the number of open loop poles on the right hand side of the S plane for the closed loop system to be stable. Okay, number of open loop poles on the right side of the S plane for the closed loop system to be stable. For the closed loop system to be stable. And guys, if you look into this, of course, this is given as infinity, right? So let's say this is -1, 0, and how many encirclements of -1, 0? You are able to feel that there is one encirclement, and that is going in what? That is going in anti-clockwise direction. Okay. So again, one encirclement. Okay. So what is the formula I use? N is equal to P plus minus Z plus, assuming to be clockwise Nyquist contour. Of course, you can assume anything. दोनों से ही आंसर आएगा. Okay, let us regularly assume the clockwise Nyquist contour. Then N is equal to P minus Z, everybody. So N is the number of encirclement. One in anti-clockwise. Anti-clockwise means positive. Is equal to P plus minus. You want the closed loop system to be stable. And here, closed loop system is stable if doesn't have right hand side poles. Right hand side poles. So Z plus ka value 0 hoga. So what is the P plus? That is 1. Okay, P plus is known as the poles of GSHS on the right hand side. So correct answer is equal to what? Is equal to A. Yes, Ravi. The correct answer is equal to A. The correct answer is equal to what? Is equal to the A. The correct answer is equal to A. Done. The correct answer is equal to A. Okay. So N, number of encirclements of -1, 0. P plus is the number of poles of G. If you have forgotten, please listen to me and write down. P plus is the number of poles of GSHS in the RHP. Okay. Now poles of GSHS means open loop poles. Z plus means the zeros of 1 plus GSHS. That is roots of characteristic equation in RHP. Roots of characteristic equation means poles of closed loop system. Okay. Poles of closed loop system. And for the closed loop system to be stable, how many poles in RHP? Nil. That is why I take Z plus equal to 0. Next question, number 16. Okay, so there are two compensator transfer functions given. Which of them is lead, which of them is lag? Which of them is lead, which of them is lag? Very fundamental question it is. A very fundamental question. So 6 S plus 1 divided by S plus 6. Divided by S plus 6. Okay, so what is the pole and what is the 0? Pole is at -6. Pole is at -6, 0 is at -1, and which is closer to the origin? -1. So it is 0 dominant. Excuse me. Sorry, dear. It is a 0 dominant system, and that is why it is a lead compensator. It is a lead compensator, right? On the other hand, C2 is given as S plus 6 upon 6. S plus 1. So what is the pole? Pole is S equal to -1, and what is the 0? Is S equal to -6. So what is closer to origin? Pole is closer to origin, and whenever it is pole dominant, it is a lag compensator. C1 is lead, C2 is lag. Correct answer, yes, Ravi. C1 is the lead, C2 is the lag compensator. C1 is lead, C2 is lag. C2 is equal to lag. Done. Next question here. For a phase locked loop system, the open loop transfer function is given to you. 1000 upon S, S upon 1192 plus 1. The phase margin is 50 degree and the crossover frequency is approximately 1000 radian per second. 1000 radian per second. इस initial data की अगर हम बात करें, if I want to talk about this data, the phase margin is 50 and the crossover frequency is 1000. A time delay is introduced in the phase detector, reducing the phase margin to 40 degree. What is the maximum permissible time delay? Time delay. So what is the time delay element actually? The time delay element is known as the exponential term e power minus st. The time delay function is the e power minus st because when you take a system with the input xt, okay, and let's say the transfer function ts, and the output yt. Delay means yt should be x of t minus t, delayed version, and Laplace transform will become x of s e power minus st. So what is the transfer function y by x? It is e की power minus st. For a time delay system, the transfer function is e की power minus st. Clear? E की power minus st. ठीक है? So this time delay is introduced, okay, which is reducing the phase margin to 40. What is the value of the time delay? ये figure out करना है. Okay, but guys, when you see that, you are now having g of s e power minus st as the new transfer function. Suppose the new open loop transfer function is going to be g of s is multiplied by e power minus st, or if I convert this into the frequency domain, I write this as gj omega e raised to the power minus j omega t. So taking the modulus of this, modulus of g1 omega will be equal to what? Modulus of g omega into 1, because mod of e power j theta is always 1, cos square theta plus sin square theta ka under root. Okay, that means guys, the modulus of g1 omega, the modulus of g1 j omega will be modulus of gj omega. So number one point is gain crossover, the gain crossover frequency, which is calculated by mod of j omega, mod of gj omega equal to 1, that remains to be same, right? So what is going to be same? You have same gain crossover frequency, that is 1000. Clear everybody? Gain crossover frequency is calculated by putting the magnitude function equal to 1, and this time delay term will not affect the magnitude. That is why it will not affect the gain crossover frequency. It is not going to affect what? The gain crossover frequency. It is not going to affect the gain crossover frequency. ये भी done है? ठीक है. चलो, so gain crossover frequency remains to be same. Okay, but what is going to be the phase? अब इसका अगर मैं original phase निकालूं, the original phase margin is 50 degree. Original phase margin. Okay, that means 180 degree phase margin formula plus angle gj omega g, angle of the original gj omega, this is 50. This is 50. Okay, 180 plus angle gj omega, ये 50 है, right? Now, what is the new phase margin? राइट उसके लिए पहले मैं एंगल जीजे ओमेगा निकालूंगा, नॉट जीजे ओमेगा, एंगल जी1 जे ओमेगा. नाउ व्हेनेवर टू कॉम्प्लेक्स फंक्शंस आर मल्टीप्लाइड, their angles are added. So angle g1 j omega is angle of gj omega plus the angle of e power j theta, that is equal to theta, that is minus omega t. ठीक है, minus omega t. That means dear, if I put omega equal to omega g, which is 1000 actually, so angle of g1 j omega g should be angle of gj omega g minus 1000 into t. Minus 1000 into t. Okay, but because I'm using omega t, it is in radian, so isko bhi radian mein rakhna padega dear. So what is the angle gj omega g? Angle gj omega g, that is equal to minus 130 degree actually. ये कितना हुआ? 50 minus 180 minus 130 degree. Okay, minus 130 degree. So this is minus 130 degree, but I cannot write in degree because the other term is in radian. So you can use the conversion. Now 180 degree is equal to pi, right? So how much is 130 degree? That is pi by 180 into 130. Okay, so इसको लिख दिया यहाँ पे कितना? इसको मैंने लिख दिया, that is 13 by 18, minus था actually, minus 130. So minus 13 by 18 pi minus 1000 t. Okay, now what is the new phase margin dear? What is the new phase margin? Yeah, इसको degree में कर लीजिए, anything. If you want, convert this to degree. So how much will be this? Sorry. Okay, how much is this? Minus 130 degree minus 1000 t into reverse, and the reverse will be 180 degree divided by pi. 180 degree divided by pi, that is no value of 1 radian. Okay. Now the new phase margin. The new phase margin is 40 degree. That is 180 degree plus angle of g1 j omega g. That is 40 degree. So that means angle of g1 j omega g should be minus 140 degree. So hence I can say माइनस 140 डिग्री, पिछला वाला फॉर्मूला उठा लेंगे, शुड बी इक्वल टू माइनस 130 डिग्री माइनस 1000 टी इंटू 180 डिग्री डिवाइड बाय पाई. ओके गाइस, सो लेट्स सॉल्व दिस क्विकली. सो ये कितना हो गया, 1000 t इंटू 180 बाय पाई. दिस इज इक्वल टू, ये लेफ्ट में आ गया तो 140 माइनस 130, दैट इज इक्वल टू 10. सो व्हाट इज द वैल्यू ऑफ t? द वैल्यू ऑफ t विल बी इक्वल टू पाई, ये हुआ डिवाइडेड बाय 180 इंटू 100. 10 से एक बार कैंसिल हुआ, पाई अपॉन 180 इंटू 100. ओके, सो 10 की पावर -4 में होगा. लेट मी जस्ट डू द कैलकुलेशंस गाइस. इसको कैलकुलेट किया मैंने, जस्ट 1 सेकेंड. डिवाइडेड बाय 18 है, सो 0.174 इंटू 10 रेज टू दी पावर -3, एक्चुअली इंटू 10 की पावर -3 इंटू 10 की पावर -3. या सो 0.174 10 की पावर -3, एग्जैक्टली ऑप्शन नंबर डी. ओके, दिस इज द ऑप्शन नंबर डी, एग्जैक्ट मैचिंग. गुड क्वेश्चन गाइस, दिस इज अ गुड क्वेश्चन. ठीक है, बट ऐसा है कि बार्क में गुड क्वेश्चन नहीं आता. यस, बार्क हैज गुड क्वेश्चंस आल्सो. Barc has good questions also. Okay, now it is, first in the Barc exam you should have a wise choice that attempt a simpler question come first because time is less. Attempt the simpler questions first, time less hota hai. Acha, or else don't worry, the cutoffs are also low. If you get good questions in Barc, time is limited, the cutoff is also accordingly low only. Okay, chalo, around 50% also if you score, you are mostly in the safe zone. ठीक है, moving ahead to the next question. A unity feedback closed loop system has a plant GS equal to 1 by S square and a PD controller GCS in the forward path. If GCS is equal to TP 1 plus STD, where TP and TD are positive adjustable parameters, which of the following statement is not true? Is not true, मतलब false select करना है. The system is always stable. Okay. The system is always stable. अब देखो क्या होगा. What is the characteristic equation? What is the system actually? There is a plant with the transfer function 1 by S square. Okay, and then there is a PD controller. So first I should be writing the PD controller actually, and that is given by the transfer function TP into 1 plus STD. This generates the required actuating signal to be applied to plant. Plant gives the output C, and then this is connected in unity negative feedback fashion. Okay. Now, what is the characteristic equation then? The characteristic equation is 1 plus TP 1 plus STD multiplied by S square equal to 0, or S square solve किया पहले plus S TP TD plus TP is equal to 0. Clearly mentioned, both TP and TD are positive parameter. Positive, so product of positive is positive. 1 is always positive, so this is always stable. This is always stable, right? So this is a true statement. We have to think what is not true. The system may have damped oscillation for unit step input, right? Whether it has damped oscillations or undamped or overdamped oscillations, or whether it doesn't have oscillation, it depends on what? It depends on the value of zeta. Right, depends on zeta, and zeta depends on TPTD. So there is a possibility. ना, it may have, sure नहीं बोला है. So this is also true, right? ये true हो गया, because it depends on what? It depends on zeta, and zeta further depends on TPTD. Okay, the system amplifies the noise. Okay, now here you have to apply one concept. Okay, of what? Of the PD controller. और फिर लास्ट में भी आते हैं, system has zero steady state error for parabolic input. Is it correct? ये यहीं से समझ में आ रहा है. Is that correct? चलो पहले C की बात कर ले. Does it amplify the noise? So what is the effect? What is the effect of bandwidth? Okay, by a PD controller. So PD controller actually increases the bandwidth. The PD controller actually increases the bandwidth. It reduces the rise time. तो अगर मैं PD controller की बात करूं, right, it reduces the rise time. It reduces the rise time. Clear? Rise time, settling time, everything it reduces, right? And hence it increases the bandwidth. And whenever the bandwidth of a system is increased, it is more prone to noise, because noise is also a high frequency component, right? So option number C क्या बोलता है? It amplifies the noise. Yes, because the bandwidth increases, it amplifies the noise. Okay, so third bit true ho gaya. Now system has zero steady state error for unit parabolic input. Okay, so now what is the overall open loop transfer function? Overall GS, in दोनों को multiply किया. So I have TP 1 plus STD divided by S square, which is what? Which is a type 2. Unity feedback mein, so I can talk about the type. It is a type 2 system. It is known as a type 2 system. Clear hai? It is known as a type 2 system. ठीक है, done. If it is type 2 system, what is the steady state error? किसके लिए बोला है? Parabolic के लिए बोला है ना? No. Steady state error for step will be 0. For ramp will be 0. But for parabolic, it will be 1 upon Ka, which is going to be finite. 0 नहीं होगा, non-zero finite होगा, because Ka can be calculated. Ka का value आ जाएगा Tp. Okay, so D is the correct answer because that is false. This statement is not true. This statement is not true. This is false. Done? So correct answer for the question is D, dear. Everybody. Correct answer is equal to D. Chalo. So these are the solutions of 18 questions. The DPP I already shared in the Telegram. Okay, the solutions also I will also share. The solutions also I will share. And let's say the password for the PDF is going to be face. The solutions will be, the PDF of the solution will be password protected. The question PDF is open, that is shared to everybody. But this PDF is going to be password protected. And the password is going to be PHASE face. PHASE face. And you can find this in my Telegram group. I'll share you today the solution of whatever the questions we have discussed. Okay. So yes, guys, the GATE 2024 fundamentals is also live at 9 PM. And guys, tonight you have the class of fundamentals, very fundamental and interesting and important topic, that is the Ohm's law, right? Ohm's law tonight at 9 PM, and that is going to be taken by your favorite Ashu Jhangra sir, right? So tonight Ashu Jhangra sir will going to take the class for Ohm's law in the GATE 24 fundamentals. All right, you can search by my name, Conquer GATE and ESE by Rakesh Talreja, John Akhil. Okay. Chalo guys. So hope you have enjoyed the session. Okay. Nah Ravi, nah, don't worry. First focus on interview will guide you regarding the, first focus on the written will guide you regarding the interview also. But that's difficult. It is difficult, we know, but it is nothing impossible or nothing really tough. We can put it as yes, difficult. चलो Telegram link में एक बार share भी कर देता हूँ. This is the Telegram link where you will be finding the PDF. Okay. Chalo guys, bye bye. Thank you. Stay safe and take care of yourself. See you in another session.